Our species of human beings, Homo sapiens, is today the only kind of human on the planet. But we know that wasn't always the case. For a very long while, modern humans coexisted with Neanderthals, and we know there was another species of human, a tiny human with large feet, Homo floresiensis, nicknamed the Hobbit, that was found in Indonesia a while back. And now we know there was another enigmatic kind of human called the Denisovans. We don't really know much about what they look like because only their finger bones and teeth have been found so far. Dr. Kira Westaway is here today. Dr. Kira Westaway is a geochronologist and associate professor at the School of Natural Sciences at Macquarie University. Kira reconstructs and dates early human remains and their tools at archaeological sites to find out how and when they lived and died. Just recently, Kira was part of the team that discovered a major puzzle piece in the mystery of the Denisovans in a remote cave in Laos, in Southeast Asia. It was a single tooth, a 150,000-year-old tooth that had belonged to a Denisovan, and that was weird. Because the other fossilised remains of Denisovans have been found far, far away in much colder habitats in Siberia and Tibet. Kira is at the forefront of the investigation into these mysterious people and how they migrated across the planet and interbred with modern humans far out. Hello, Kira.
Hello, Richard.
Who were the Denisovans? What can you tell me about them as people?
Well, we know them as a human group. We know more about their DNA than we actually know what they look like, which is probably the only species of human that we do know more about their DNA, which is incredible. And the reason we know more is because DNA, ancient DNA, is really well preserved in really cold environments. So we've got the caves in Russia, Denisova cave, and we've got the Tibetan plateau. And because it's so cold there, the ancient DNA is really well preserved. So although we only found a tiny finger bone of this human group, we were able to reconstruct their DNA. So we've been able to have a look at where they sort of dispersed, when they migrated, based on their DNA, which is really interesting.
Do we know if they were tall or short, whether they had big heads, small heads, large feet? Can we tell anything about them at this stage?
Not so much. We only have their teeth, obviously, and finger bone and other sort of undiagnostic points, so bones that we can't really tell much from. We know that they were potentially similar to modern humans and Neanderthals, but again, we don't really know. All we know is their DNA, and from their DNA we can reconstruct their path, like where they dispersed across, down through Southeast Asia, down into Australasia and Australia.
So the Denisovan, and presumably there was more than one Denisovan living in that part of the world, in Southeast Asia and Laos. Do we know if they were the first humans or humanoids? And what do we call them anyway? Do we call them humanoids, humanids, humans?
We can call them humans. We can call them hominin. We call them a hominin group.
Right.
Because some people have always asked me, like, is it a different species? And the thing is, the definition of a species is that you've got two groups that they can't produce a viable offspring. That would define them as species. But we know that modern humans and Denisovans and Denisovans and Neanderthals could produce a viable offspring. But they do have very different evolutionary paths. So they're kind of at that point now where we don't really call them a different species because they haven't been separated for long enough to actually be that different. Do you know what I mean?
So were the Denisovans in Laos, were they there before Homo sapiens, before modern humans walked over from Africa?
Well, so they were there. We know from the dating of this tooth that they were there about 160 to 130,000 years ago. So that's definitely long before modern humans were there. But what's really interesting about the timing is that they were in Laos at the same time that they were actually in Russia and on the Tibetan plateau.
Yeah, now that's weird, isn't it? Is that weird, or am I just thinking that's weird?
No, I mean, I think it's incredible. I mean, if they were there sort of at a younger time than in Russia, then we could say, oh, they were in Russia and then they migrated down into Laos. But because they were at the same time, we don't really know which was there first. So it doesn't really tell us about where they came from, but it tells us they were there at the same time.
So at what point when these first remains were found did we realise that we had a whole different kind of human on our hands here?
Finding the finger bone, potentially knowing that it was a human finger bone, but not knowing what human bone. But obviously, because of the cold conditions, the first thing they try is the ancient DNA. And then suddenly we're getting this whole story of a group of humans that we didn't know anything about. And that's crazy. And then looking at the ancient DNA, we see that, modern Australians have a small percentage, about 4% of Denisovan DNA in their DNA. So they have actually contributed to who we are as humans today.
Well, and when you say they were able to extract DNA from this bone fragment from Russia, from this cave in Siberia, what is that DNA? Was it the tiniest bit of flesh left in there, or bone marrow or something, or just inside the bone somehow?
Yeah, so it's just within the structure of the bone, and they're looking for collagen and anything that was originally alive. Yeah,
right.
So
And so they just put that under, they did a DNA test in there and went, hello, there's some.
Yeah, so they have to
here.
reconstruct the whole sequence of the DNA. So they have these big DNA sequencing machines. It takes a long time to actually sequence the whole thing. But we obviously know human DNA, and we can see that it was human, but it also have these other links in it that make it slightly separate from that.
Why is it hard to find Denisovan remains, given that you've found, a bit of a finger and a tooth, I think, somewhere as well?
Yeah.
Is it possible you could have Denisovan bones just in your drawer at Macquarie Uni rattling around somewhere that might be Denisovan you haven't been able to identify as yet?
I think there's an interesting thing. Once they had reconstructed the DNA, then suddenly the hunt was on. There's always been some fossils that don't really sit very well in one grouping or another, and people just put them in that ancient humans group because we don't really know where they sit. And so now I think everyone's gone back and had to think about those bones that we put in the too hard basket, and reassessing. I know there's a lot of bones in China at the moment that are being reconsidered as potentially as Denisovan. And then when we found this tooth, we couldn't do the DNA because it's hot and wet is the worst conditions for DNA reconstruction. We had a look at the proteins, so the paleo proteins, and that told us that it was female, and it told us the age, probably between about 3.5 and 8.5 years old. So only a juvenile, only a small child.
Well, before we get to that, just tell me how you knew to go looking in. Given that the previous fossilised remains have been found so far away in Siberia and in Tibet, what made you think, hello, I'm off to Laos to go and look into a cave there for Denisovan remains?
We were already there, to be fair. I've been working in Laos since about 2011, and I've been working with a French-American team, and we had excavated a site called Tampaling, where they had found modern humans, originally about 46,000, and then every year they've been finding more, so it's gone to about 70,000 there. So that cave there was known as a modern human site. And what we do whenever we're at any site, we start doing reconnaissance little trips. So we go out and we have a look at caves, and we come back and then go out again and do little scouting trips. We ask locals about where they've seen caves, where they've seen fossils, because a lot of the locals are quite aware of these caves.
So to do that, do you have to... Do you have to kind of think like this ancient human? Do you have to sort of walk around these spots and go, this would be a nice spot for shelter and to light a fire?
Yeah. There is definitely that. If you're looking for occupation caves, you definitely think about, would ancient human be able to live here? Is it an inviting place? We know that they don't go to the back of caves. They usually sit what we call the drip line. They're just in the entrance of the cave. So they like rock shelters more than they like deep caves. But there's also the type of cave which is just a sediment trap. So all it's doing is channeling sediments and fossils from the landscape, and then they're like sort of washing in. So every time you have like slope wash from the hillside, they're all sliding down into and being deposited in these caves. So they're definitely not occupation caves. You won't find hearths or stone tools necessarily, but you do find fossils, and those kind of caves are the ones that really find their interesting stuff.
Slope wash is a new word for me.
Slope wash.
I like slope wash.
From the slope.
So these caves sort of become like little catchment areas.
Yeah,
in other words,
literally,
for all this stuff that just slides in
for sediments
over like hundreds of maybe 100,000 years take to wash into these places.
Yeah.
So you were just hunting around looking to see. It was a bit of a look-see.
Total reconnaissance. We knew about the cave up there. It was quite difficult. It's about 30 metres off the alluvial plain, so it's quite hard to get up to. It's a bit of a climb, but once they got up there, they just started poking around. Clement Denolly, he's one of the French team. He's a paleoanthropologist. He found the tooth. He said, "This is human."
Where was the tooth? How was it found? Where was it?
Literally just in the side of the sediment wall. So they were poking around.
Hang on, what is lodged in a wall?
Yeah, so basically it's what we call a bone breccia, which is accumulation of quite angular rocks and lots of fossils as well. And they're literally in a sediment wall.
So assuming that you say that you're able to establish that this tooth belonged to a young girl, a young Denisovan girl.
Yeah.
She died for whatever reason and her body lay there for a while. And then over time, the sediment came in and just pulled apart bits of her skeleton or something, and that's how it ended in a wall. The tooth ends in a wall.
So remember, like the landscape would have been higher, would have been at the level of the cave. The cave would have probably been lower.
Right.
So her body would have degraded down into fossils. It probably would have moved around the landscape a little bit, obviously why it's all broken up. And then at some point it would have washed into the cave and then formed in this deposit. And that's just perfect for us because you've got the fossils and you've got datable material. So it's just a perfect scenario.
Have you found anything else belonging to her? Just the tooth so far?
No, just the tooth so far. It was surrounded by lots of herbivore fauna. So there was lots of animals around that they could have potentially been hunting. We obviously know that there would have been more because it was a juvenile on her own. Like she wouldn't have been living on her own. Do you know what I mean?
She would have had mum and dad or someone around, or community, or aunties or uncles around. So this was a molar, wasn't it? How much can a tooth tell you about a human being?
An incredible amount. Teeth are like an archive of information about yourself. I mean, I work with Renaud Jonas-Boyer from Southern Cross Uni, and the amount of information he can get from teeth is incredible. They slice them open, they have a look, and it can tell things like how long you were breastfeeding for. So,
really?
Yeah, it can tell you
what? Really?
About mobility in the landscape. Right. So how you were moving around in the landscape, where you were going.
What do you mean? Like in terms of what by diet you mean?
Yeah. So they look at diets. They look at oxygen isotopes, oxygen and carbon isotopes, but they also look at trace elements, and they're looking at things like strontium, and they can get a strontium map of the area to work out the strontium levels and then work out where they were walking around based on the strontium in their teeth.
So there's like a universe of information inside a tooth, is there?
Yeah, I call them the teeth whisperers, because they seem to be able to get so much information from teeth. And teeth are obviously the most preserved of all the fossils. I mean, you're lucky if you find bone. Mostly, especially in Southeast Asia, it's just dominated by teeth. But luckily, teeth are fantastic. You can date them and you can get information from them.
So what does it mean to have found a tooth in Southeast Asia, a fossil of such a human in Southeast Asia and in these kind of colder, more mountainous places in Siberia and in Tibet? What does that tell you about the adaptability of the Denisovan?
Well, we always associate being really adaptable from modern humans, from modern Homo sapiens, because they were very good at adapting to diverse environments. But this tooth really made me understand that if they're adapting to the freezing cold of Russia, plus the high altitude of Tibetan Plateau, that's an adaptation to be able to live in a high altitude area, plus the kind of balmy hot caves of Laos, all at the same time. Now that's incredible. That's on the same level as modern humans, as being able to adapt. But remember, this is 100,000 years earlier than modern humans were in these areas. So they were actually adapting to these diverse environments 100,000 years earlier than modern humans, than we were doing it.
And yet, as you say, there are elements of Denisovan DNA in some modern humans.
Yeah.
That means, I'm afraid to say, Kira, there was some kissing and cuddling going on at some point, doesn't there?
There was some interaction, definitely.
So what do we know about that? So, I mean, not the gory details, but so humans walked over from Africa, modern humans walked over from Africa, walked across Eurasia and arrived, got into boats or arrived in this, no, not in a boat in this case, but arrived in this part of the world, and there was either war or there was sex. That always tends to be the two things, doesn't it? It's thematic or erotic, the two encounter there. So do we know when that would have taken place?
It's hard to say. I think the reason that we were so keen on looking in Southeast Asia, and this is why a lot of paleoanthropologists are looking in Southeast Asia, is because there was what we call an introgression, which would have been an intermixing of Denisovans with modern humans at certain points. And there was definitely one in Southeast Asia. There would have been one in Australasia, maybe Papua New Guinea, places like that. So people have kind of pinpointed that from the DNA structure as to when these introgressions were. And then that's kind of honing everyone in on where to look. Do you know what I mean?
Is Southeast Asia such a place because it's so lush and so abundant in food, I wonder, as opposed to some sort of bleak tundra in
I mean,
Siberia?
I definitely think that there's that to it. But I also think it's because of the expanse of limestone. Because we have limestone caves, then we get these incredible sediment traps and that are preserving all this material. Without the limestone, we wouldn't get the caves and then we wouldn't get this preservation. So obviously you've got the occupation side where they were caves for them to live in, but also this sediment trap side, which is just containing all the fossils for us, which is fantastic.
Now, you're not an archaeologist, you are a geochronologist.
That's correct, yeah.
What is a geochronologist?
So it's just really about time. I'm a time lord. I try to reconstruct when events happened, and the dating technique I use is luminescence dating. It's actually optically stimulated luminescence. So,
what is that? What is luminescence? What is glowing here?
Well, the actual signal is glowing. So it's a light sensitive signal that is sort of reset by sunlight. So we're looking at minerals such as quartz and feldspar. So unlike carbon-14, which is organic dating, like dating something that was alive and then it decays, this is inorganic. So quartz and feldspar were obviously never alive. They're just minerals. But because they have this crystalline structure, they can retain a signal when they are buried. When you expose them to sunlight, they are reset to zero, but then when you bury them, they start to build up with this signal.
Far out.
I know, it's crazy.
That's amazing. And where are you extracting these tiny, I'm assuming these are tiny bits of quartz and what have you, like what, immediately around or in the bone fragment or something?
We'll take a sediment sample. Obviously, we have to be very careful to take it in without light exposure. So we either bang tubes in or we do it, because I work in caves, I just do it in the dark.
So you're standing in the cave going, don't point a torch.
Yeah, no, there's absolutely no torches. People go, can I take a photo? And I'm like, no. Yeah, so it's all about light. I'm very paranoid about light.
So you've got to go in the dark and extract the tiny soil samples then,
because I work in caves, it's quite easy just to make it, and I just go, okay, we go red light. So I have a little red light head torch, which is safe for the signal. And then I'll take a sample and then we'll take it back to the lab. And then obviously I have a very dark lab, a red light lab. And then I process the quartz and feldspar or feldspar and get it down to a mineral. And then I fire a laser at the sample, and that gives it energy so that the signal actually comes out. And the amount of light that comes out is proportional to how long it's been building up that signal in the barrier.
That's amazing. Like the tiny little bits of quartz and feldspar can be emitting a signal, I suppose. I know. It's a signal, isn't it?
Yeah, it's a signal, and it comes out as light. Very, very dim light, but we have photomultipliers which are able to measure a very, very dim light. And that's basically how the process happens. And what's incredible is that any sediments that you find anywhere in the world will have either quartz or feldspar in them. Some will have just quartz, some will have just feldspars, but you'll have one or the other. So that means anywhere that there's sediment buried, I can date it. And it's not just the sediment I'm dating the fossils and the stone tools and any other artefacts that's inside the sediment at the same time.
How precise is it?
That's the golden question, isn't it? We do have a lot of uncertainties in luminescence because there are lots of elements to it, but we can get, 5 or 10% error margin, which is not too bad. Luminescence can go down to about 100 years, so I can date something that's only 100 years and up to, depending on the conditions, we can get up to like 800,000, 1 million years old sometimes. So, yeah.
So does that mean you can get it down to that's like to the nearest 100,000 years or the nearest 10,000 years or something like that? Or
with an error of only 5%, it's not that large an error gap. So yeah.
I'm gathering you probably thought you always wanted to be a scientist, Kira, but I don't suppose everyone wakes up going, I want to be a geochronologist.
No, exactly.
How does someone like you end up in a line of work like this?
I actually, when I was younger, wanted to be a teacher. My mum used to tell me that I used to line my dolls up and teach them classes and stuff like that. And then I got to uni and I was like, yeah, no, I want to go into science. I want to be a lecturer. That's what I want to do. I was originally really into process and landforms. So physical geography used to be called then. It's more like earth and environmental sciences now. I really like, just looking at a landscape and kind of working out how it's been formed and that the processes that were involved in creating landforms.
So is this come from a love of a fascination with deep time?
Definitely time, but I think at that time when I was really into that, I wasn't so aware of the time element. I was more into just the process. And it wasn't until I did a master's in London that I was introduced to luminescence dating. And I was just amazed because it's like, not only do you know what process happened, you know when it happened. A very wise colleague said to me, we kind of know what happened, we just don't know when it happened. And when became this amazing tool, especially luminescence dating became this amazing tool in which I could not only work out how things happened, but when they happened. And the whole time it became this huge thing because you give things context by saying when they happened, So a stone tool could be just a stone tool, but then you date the sediment around it. It could be the first time that a stone tool has ever been made on that continent. And suddenly you have this tool where you can tell exactly when things happened. It's almost like a time machine. You can go back 100,000 years to a precise moment in time when that fossil was deposited in a cave. And that's an incredible thing to be able to use in science.
So was it straight from there to the caves of Laos, or did you make a couple of pit stops on the way?
A couple of pit stops. I did a master's in Hong Kong in luminescence dating as well, and obviously got the travel bug a little bit when I was living in Hong Kong. I was there for the handover. And after that, I was just like, I just kind of want to travel a little bit. So I was a dive master at the time, so I was really into diving. And then I went to Thailand and ended up being an instructor and running our own scuba diving shop for about 4 years in Thailand.
Yeah, sounds glorious. What got you out of the scuba dive shop and back to sciencing, if that is indeed a verb?
I kind of had a deal with myself that, it's all fun to big traveller and do all that fun stuff, but I wanted to do a PhD by the time I was about 30. So I sort of put the feelers out to do a PhD, and Professor Richard Roberts from University of Wollongong contacted me. He actually phoned me in England, and my mum was like, oh no, she lives in Thailand, So he sent me an email and he said, oh look, we've got this great project, obviously not a famous cave at the time, Liang Bua, and we'd love you to be involved in it. And he said, just have a look to see what you think. So I had a look at the website and it said, beautiful rainforest campus overlooked by Mount Kira. And I just had I had this moment. I was like, do. And I was like, I have to go and do it. Like, I've never been so sure about anything in my life, and I talked to my mum and she said, okay, we'll just, sell up your dive shop and go to Australia. And that's what I did.
So your first field trip then was to this place called Liang Bua.
Yeah.
What was the mission? What were you initially setting out to look for?
Mike Morwood and Bert Roberts had been working a long time on Flores, and they'd worked mostly in Soa Basin, which is in the middle.
Now Flores is this island
in Indonesia,
to the west of Timor, isn't it?
Yeah.
That's right. South of Sumatra.
Yeah, that's right.
It's not far at all from Australia. Then.
No, it's really not. Yeah. It's basically from Bali, which everyone knows Bali. It's a couple of islands across, and then you get to Flores. But incredible island. It's a really interesting mix of Christian and animist. So they go to church on Sunday, but they still sacrifice animals, So it's like this really interesting mix. And that's what I love about Indonesia. You go to different islands. Every island's got a different religion, a different feeling about it. And they knew about this cave because this priest called Verhoeven had worked there, and he'd done some preliminary sort of excavations and found lots of Neolithic burials and pottery and all that stuff. So they knew it was an interesting cave, and they'd estimated how deep it was. So they knew it had great potential. But at that point, it was just, go to the cave and do some dating and see what happens, And
what did you think you'd find there? What were you hoping to find in that cave?
We were hoping to find modern humans, evidence of modern humans coming down through Southeast Asia, through Indonesia, down to Australia. That's what we were really looking for.
So you were trying to map human migration into the area.
Yeah, and we just thought it was a useful stepping stone on the way. If you look at the islands, they look like they would be a nice stepping stone. We've since found that because of this thing called the Indonesian through flow, it's actually very hard to go across that island chain. But at the time, we thought Flores would be a useful stepping stone on the way.
And tell me how the team made this amazing discovery there.
So we'd been there for 3 months, and we'd excavated a number of pits, and we were down about 3 or 4 metres in this one sector. I actually had a photo of me sitting there with Thomas Sutnecker, who's the director of the dig, and I was just taking a luminescence sample, and I was sitting on this big pile of where they were about to excavate. And then I left and went home to Australia. And by the time I got back, I walked into Bert Roberts' office and he said, they found a skeleton. And Thomas told me to tell you it was right where you were sitting.
And how big was the skeleton?
So it was quite obviously it's a small skeleton because it's, a small hobbit, we know now. But it was quite sort of all jumbled together, so it wasn't over a huge area. But when they thought it was a child because it was so tiny. And as they took about 3 or 4 days to, harden the bones and make it so it could be moved. And then as they were carrying it out, my friend who's a paleontologist, he was looking at it and he could see that the wisdom teeth weren't erupted at the back. So he knew it was
a whole different kind of human.
Podcast, broadcast. You're listening to Conversations with Richard Fidler. Hear more conversations anytime on the ABC Listen app, or go to abc.net.au/conversations.
When she was found, the skeleton, you said first they thought this is a human child. How did you and they know she was not a human child?
The skull was small, the bones were small, so they just thought, oh, it's a juvenile. But as they started to take it out, they realised that the molars were erupted already. It was at least 30 years old. It wasn't,
all her teeth were down.
Yeah, the teeth were all down. They were all out. So it wasn't a child. And so they were like, what is this? Do you know what I mean? Like, they were really, really confused. And it took a long time for us to really sort of get our heads around what it could actually be. We know that it was human, as in Homo, but definitely not a modern human. So we came up with a different name, Homo floresiensis, for the Flores Island. But yeah, when we came out with it, it just, as you know, caused a massive uproar. I think most of the science community were just stunned, like they didn't really know what to make of it. So for a while there was a kind of a silence. Do you know what I mean? Obviously the media were going crazy over it and all that sort of stuff.
I read every story that was going around about it.
I know. It was
new kind of human found. Yes, it's kind of an exciting story.
So I was a new PhD student, obviously, and we had to go down to the Australian Museum to do the press conference, and it was one of those things where when they have all the microphones around.
Right.
I felt like I felt like
you got hats,
it was
did you? Right.
it was just felt like I was the president. When they talk on one of those podiums with all the it was crazy.
So did you get to say, ladies and gentlemen, we have found a new kind of human?
We got a new human. As a PhD student, it was a bit crazy, to tell you, a bit of baptism with fire, really. But then after, it had kind of sunk in, then everyone, the skeptics kind of came out. And
that's appropriate, isn't it?
Yeah.
I mean,
that's science. That's how science moves forward.
So what were the skeptics saying about this?
So the skeptics were saying it was a modern human, but it just had some sort of disease. And we sort of jokingly referred to it as disease of the week, because every week there was something that it could have had, an iodine deficiency. It could have had microcephaly, which is, a deformation of the head and everything. But every week there was literally a different disease that it could have had. And we just stuck to our guns and said, it's not a modern human. It doesn't have any form of chin. Now, obviously, the chin is a structure that modern humans have. And the Hobbit doesn't have a chin. So we were always saying, look, if you can find me a disease that gets rid of your chin, then we'll start talking. But until then, we just stuck to our guns. And
why was she nicknamed the Hobbit? What was it about her that made her Hobbit-like?
Yeah, it's very funny. I was actually sitting with Mike and Bert when this name came out. And we were sitting there and we were thinking of sort of potential names that it could be, throwing around names. And then Mike just sat there and he just sort of had this smirk on his face. And he said, what about the Hobbit? And I was like, what? He said, well, think about it. It's small, it's got big feet, and we got it from a hole in a cave, And he said, that's just the Hobbit, isn't it? Or Hobbit, rather than the Hobbit, he just called it Hobbit. And he wanted to call it Homo hobbititis or something like that, some sort of Hobbit name. And we managed to pull him back from that.
Okay.
Yeah. And we're throwing around lots of different names, but then in the end we thought floresiensis was the best, most appropriate name.
So when you say small, how small?
So the size of a 3-year-old child.
Oh, that's small.
Yeah, so it basically up to your hip bone was the size, and it still freaks people out now. At the time,
I was thinking like a 10-year-old or something.
No, a 3-year-old child. So I had a small child at the time, and I just, every time I saw him running around, I was thinking, goodness me, a grown adult human, definitely about 30 years old, was running around at that size. And not just one, there was a whole community of them.
And what state were her bones in when they were found?
Obviously, any excavation, you're gonna find some preservation issues, but this had been obviously buried for a long time, 50,000 years or so, and the excavators was telling me that they felt like wet blotting paper. They were so thin. They felt like they would just break if they got picked up. So they had to get lots of hardeners and things to paint on the bones so that they could withstand being able to get pulled out of the excavation. But they took about 5 days to get it out, apparently.
What time frame was your analysis able to place her in? Like, how long ago was she living there?
Yeah, so I had obviously serendipitously had taken that sample right above where she was found. So I already had a sample of in the sediment. So I came out with the technique that I did. I came out with about 36,000, and then we had dated.
That's not so long ago, is it? Really,
no.
in these terms, is it?
So we had dated some charcoal with radiocarbon dating, which is obviously dates something that was alive and then decays. And that came out about 18,000. Now, when we told Mike Morwood these ages, he didn't know. He's like, I'm going to go and have a beer and think about it. So he just couldn't get his head around it. Now, since then, obviously 10 years later, we've done 10 years of excavations at that cave, and we got a much better understanding of the stratigraphy, the pattern of the sediment and the relationship with the fossils. And we discovered that what we were actually dating was a younger infill sediment that had actually deposited around these older bones. So if you imagine they're kind of like a cliff of older material, and the bones were kind of eroding out of that, and we had dated the sediments around it. So then we did a redate and discovered that there's more like about 50 to 60,000, and we actually dated the bones as well this time, which helped.
Were there modern humans living on the island at the same time?
Yeah, so we know that...
Good God!
Yeah.
Because they were coexisting.
I know. So for a while, we were confused because we had the Hobbits up to 18,000. We were confused a little bit about what was Hobbit material and what was modern human. But since we got the correct age for the Hobbit material, about 50 to 60,000, then we could see that there were actually evidence of modern human there around a similar time. So we know that they would have been around the island about 40,000 at least. I mean, I obviously in Sumatra I had found the modern human teeth about 73 to 63. So we know they're around. So they're in the same place at the same time. Did they interact? We don't know. know.
So you're working, but you've got much more to work on here than you have with the Denisovans. You've got more than a finger bone and a tooth.
Yeah.
So
almost a complete skeleton.
Yeah. And were there tools around nearby as well?
So
her tools or tools of her people?
Yeah, definitely. So we have what's called a living floor, where you have an excavation layer that just has stone tools and bones and hearths, and you could almost see people sitting in the cave and living there. You know, some of the stone tools, the excavators, when they were digging, they would dig, and then one guy actually cut his hand on a stone tool. It was still sharp 50,000 years later.
And what do we know about how they were living and hunting, the Homo floresiensis people?
Yeah, so we know that they were killing and dragging carcasses back to the cave.
Carcasses of what?
Carcasses of juvenile stegodon, which is a prehistoric elephant, and
what?
also Komodo dragon. Yes, everything's small on this island, apart from the Komodo dragon, which are very large.
Bonsai humans attacking bonsai elephants?
Yeah,
wow.
I know, it's crazy, isn't it?
Did you just say Komodo dragons?
Yeah, Komodo dragons as well. Definitely found bones of Komodo dragon, cut marks on the bones. So they were definitely taking down Komodo dragons. I mean, Komodo dragons are very fierce. I went to Rencha Island just to go and see Komodo dragons, and we were actually in the ranger station, and this deer decided to run into the actual village, and there was I just saw this flash behind it. It was like a Komodo dragon moving so fast, it was like a bullet. I couldn't even see it. And they got this deer, and there's about 3-4 big ones, and they basically, over the space of about 2 hours, proceeded to eat the entire deer. And at the end, this massive Komodo dragon picked up the skull, threw it in the air, caught it in its mouth, and just ate the whole thing.
Oh, my God.
I was just sitting there going, oh, my goodness. And they eat everything. They eat the hide, the hair, the bone, everything. They eat everything. It's incredible.
And are you telling me that these people who were the size of 3-year-old children were hunting and killing Komodo dragons?
Yes.
Maybe they built traps. Maybe they built pits. How big were their heads and how big were their brains?
So Homo floresiensis had a very small head with a brain the size of no bigger than a chimpanzee. Were they really tiny?
So were they, I know these are really subjective terms, but were they as intelligent as chimpanzees or more intelligent as intelligent
I would
as
say,
us?
I would say more. Obviously, chimpanzees use they use tools to help them do things, but they don't necessarily make tools. Do you know what I mean? And that's the definition. And so Homo floresiensis had adaptations that helped them to sort of rise layers above, I would say, the abilities of a chimpanzee. So.
And so we think they were quite intelligent then, by not the same kind of capacity as modern humans, or not. I don't know. What's the
it's hard to
thinking on that?
say, because we don't see them doing the same sort of skills. They obviously had different skill sets that they used, but I definitely think that this is one reason why people really struggled with the discovery, is because it really turned on its head everything we believed about being human. We believed that, your brain gets bigger, you become more intelligent. And then suddenly there's a hobbit with this tiny little brain and yet displaying signs of being intelligent. We knew that hippos and elephants could shrink down on islands, so that they have this thing called island rule, where mammals will always reduce down over evolutionary time, obviously, down to a smaller, more manageable size to deal with the limited resources. And we knew that animals did that. We had no idea humans did that.
Yeah, you see, I wouldn't know how to take out a Komodo dragon. I mean, my preferred hunting technique for Komodo dragons is to fire a laser from space at them. I think that's and without that space laser, I'm not quite sure what I'd do.
Yeah.
So they had to be pretty smart to hunt and kill Komodo dragons.
Yeah, I mean, we don't have any evidence of that, obviously, but the fact that there was Komodo dragon carcasses in the cave, and it looked pretty premeditated, as in, that was part of their hunting strategy. So, yeah, it's pretty incredible.
It's a really weird question to ask a scientist, but did you feel any tenderness towards that skeleton? I mean, this tiny humanoid creature who lived and died all those years ago, and died where she fell, I assume, and that's all that's left of her, and nothing of her people remains. Yeah. Is that something poignant in that?
When you excavate these sites, you spend, 3 or 4 months there, and you get intimately involved with, the tools they were using. And I used to sit and just imagine them sitting in the cave and not obviously the entrance of the cave, not further back, but just imagine them sitting there in communities. And I did a lot of reconstructing of what the cave would have looked like at certain times. And I could also, at one point there would have been a little bit of waterfall at the cave. There would have been definitely a big pool down the side. And when she died, she just slipped down into this pool, and which was very, very fine material, like silty, and literally it covered the entire skeleton. Because usually in places like Flores, you don't get skeletons because the Komodo dragons eat them.
So you think she might have drowned then?
No, I think she died, and then the body just slipped down into the pool. And that's why we think she was so well preserved, because the body was covered instantly in the silty pool. And then obviously it wasn't eaten by Komodos, because any other fossil that dies on the landscape will get eaten by a Komodo dragon, and then there's nothing left.
It sounds like her life would have been pretty good if it weren't for all the Komodo dragons trampling around the place. But then, I mean, life would have been, in some ways, aside from the Komodo dragons, quite idyllic. I mean, there's superabundance of food in that area, warm, fresh water, rain, all of those things.
Exactly. Yeah. And we did a lot of looking at, when they were occupying the cave and when they were sort of more on the landscape. And we discovered that when it was really raining a lot, they tend to occupy the cave. You think, oh yeah, because it's raining. But it wasn't really that. It was more because of the rainforests. The rainforests are quite difficult to live in and quite difficult to hunt in. So when the rainforests were quite advanced, they were living in the cave. And then when it was much drier and it would have been more open plains, that's when they were coming out more and not really living in the cave so much. So it's quite interesting.
So can we now assume then, on the basis of your dating and other people's dating as well, that there was a time when modern humans were walking the earth at the same time as Homo floresiensis, the Hobbit, and at the same time as Denisovans? We were all wandering around on the planet at the same time?
And the Homo luzonensis that they found in Philippines as well.
There's another kind of human?
Another one, yeah.
So is it... I mean, how many different kinds of humans could there... I mean, we don't know, I suppose, but is it possible there could have been like 20, 100 different kinds of humans walking around?
I don't know about 20 or 100, but definitely I don't think this is the last chapter in understanding what was around. I mean, Southeast Asia has been pitched as this hotbed of human diversity and human evolution, and the more we dig and the more evidence we're finding, it's showing us that, this is the area to dig, this is the area to look for all this incredible evidence.
Is it too simplistic to say this, but is it possible to sort of construct a theory that says when Homo sapiens, us, came out of Africa and wandered across, we pretty much wandered into these areas and displaced all those people. Like when we got there, they stopped being there after a while, like Neanderthals.
Yeah,
and others.
I think rather than like we would, I don't, it's not a kind of a driving them out in any way. I just think that modern humans were much better at adapting to specific niche environments. So they were very good at hunting for marine life around the coastal areas, and they were very good at adapting to rainforest conditions. And I think that they just outcompeted any other sort of humans, and we know this happened to Homo erectus in Java, and may well have happened to other species they encountered as well.
Because I think the story I was given when I was a teenager or when I was a kid was, and it was the bad news story. It was a bit like Lord of the Flies, that humans are basically bad, and that when we come into an area, we perform some sort of genocidal practice upon other people. I wonder if that was kind of in response to the bad news when we got out after the Holocaust, in a way, that we knew suddenly this unthinkable thing had been perpetrated, and we knew now that humans for sure were
could
be this evil, that we were inherently this evil, and therefore wherever we go we perform mass murder on anything that looks a bit like us, but it might be a bit different. I wonder, but that's not really the case. That's changed now. The conventional wisdom on that's changed.
Yeah, I definitely think it's more about modern humans just being able to adapt to certain conditions, and other hominins just not being able to adapt in the same way. So kind of out-competing them rather than, going in and taking over kind of thing.
So much of your work is done in caves.
Yes.
Kira?
Yeah, I love caving.
You do?
Absolutely love it.
Really?
Yeah, I recently, just a couple of weeks ago, took all my students caving. And for some of them, it's the first time they'd ever even been in a cave. And yeah, they loved it, absolutely loved it.
You're not claustrophobic?
No, love it. I feel...
Can you wriggle through those tiny spaces?
Yeah, I feel...
Oh, I don't know how you do
I feel
that.
very at home. I feel it's kind of safe and warm, and I love
Womb-like.
it. Love the feeling.
Tell me about the Lida Ajah cave in Sumatra, what you were looking for when you went there.
Yeah, so this is a cave that we didn't primarily excavate it. It was all been excavated by Dubois, like over 100 years before. And he had found some modern human teeth, and he'd found evidence of this rainforest fauna, suggesting exactly the conditions for modern human dispersal through Southeast Asia. And yet, because it hadn't been properly dated, it just wasn't really on the map. It wasn't on anyone's radar. It was never even considered when they talk about human dispersal and the models of human dispersal. And it just wasn't there because it hadn't been dated. And this is why dating is so incredible. So we were determined to go back and find it. And so we had a copy of Dubois' original map, 100-year-old map. It wasn't the actual original one, it was a photocopy. But we were kind of armed with this map. We were kind of walking through the forest trying to find the cave, and everyone had a different idea of which was Lida Ajah Cave. The locals all would say, oh, this one is it. No, this one's it. They all arguing about it. And they said, oh, look, there's one more we want to take you to. And I said, okay. So we headed up the hill slope a little bit further, and we walked into the entrance. And I literally had a eureka moment, because there was this big calcite column right there, and then you sort of go round this column and then there's another chamber behind. And that's exactly what he'd drawn on this map. And I was like, this is it. This is the cave. So we went back through to where we thought the fossil chamber was, and we found all these sediments. We started picking around, and we instantly found an orangutan tooth. And that to me makes, okay, it's old. There's something, this is the right kind of age. So we picked around, and we found all the same fauna that Dubois had described from that cave. So we took some samples for dating. And yeah, we came back and we dated it. We got 73 to 63,000 for where the fossil had been deposited. That's almost 20,000 years older than any other age that had been established in Southeast Asia.
You mean a human fossil?
Yeah, so he had found the human fossil. So we were able to reconstruct exactly where he had found it in the cave, and then go back 100 years later and take sediment for dating.
And what does that tell you about human migration pattern in this area?
Yeah, so it basically tells us that they left Africa much earlier than had been anticipated, because to get to Sumatra by 70,000 or 70 to 60,000, they must have left Africa earlier. Because some people were saying, they left Africa about 60,000 or so. Well, they have to get to Sumatra by 60. So they had left Africa earlier. They had come across to Southeast Asia and arrived in Southeast Asia much earlier. And
was there a land bridge to Sumatra in those times?
Yeah, so if you look at what we call the continental shelf, or what we call Sunda, that's all one big landmass. So especially in periods of low sea level, you can walk straight down to that point. So yeah, they could have got there quite easily. And then that kind of opened up, well, that then has implications for the timing that they got to Australia. And luckily, a few months earlier, Chris Clarkson had published the exceptional work on Majabibi in northern Armland, and they had a date of 65,000 of arriving in Australia. And all of a sudden, it all just made sense. 70,000 in Sumatra, 65,000 in Australia. And suddenly we had a pathway of modern humans, an early population of modern humans that arrived in Australia by 65.
Part of the thrill of this, when you're telling me this, that sort of makes my imagination light up, is this feeling of deep time.
Yeah.
This feeling of trying to imagine how it was in this time when humans travelled so far, bit by bit by bit, and there were other kinds of humans. These other kind of humans that were there, I think we know they had language, or they would have had. I wonder if we can't tell from the fossil record whether they had anything other than a grunt or or anything that was more complex than that. I don't know, but we know they have tools. Is this the pleasure of it for you, imagining what these people did and how they lived?
Like I said, it's like being in a time machine. Going back to a time, and I strongly believe that humans dispersing across Southeast Asia down into Australia, it's our greatest human achievement. All that time ago, we go on about, we've invented the wheel and we've done this. And yeah, that is incredible. But to me, it's still human dispersal. I still think it's incredible that we made it across the world. And yet we don't really know much about it. We don't really know, we're still establishing when they arrived in Southeast Asia. We're still arguing about when they first got to Australia. And there's no real, there's, lots of people sort of swayed one way or the other, but it's not a huge consensus on exactly when things happened. And that's when dating just comes into play. It's all about timing and when things arrived in certain areas. That's why human dispersal and dating go hand in hand. They really do.
So now, Kira, I need you to tell me, finally, about your next major project, the hunt for the giant ape. Tell me about this giant ape, please.
So there was a very large, the largest ever primate to walk the planet, Gigantopithecus blackie.
Gigantopithecus blackie?
Blackie, that's his name, yeah.
How big?
3 meters tall.
Ooh.
Yeah. Most closely related to an orangutan. So it kind of branched off from the pongine sort of branch of the tree. Before orangutans. But
so you're saying if that ape walked into a room, it would be crouched over it. It wouldn't be able to stand fully erect in.
It could stand erect, but definitely would have probably walked around more on its knuckles.
No, I'm talking about the
orangutan.
height is what I'm saying.
Oh yeah, 3 meters. Yeah, it's huge. Absolutely massive.
Right, and where did this ape live, and what happened to it?
So we know it was in southern China, or China mostly, from about 1.5 million years ago. And then it sort of had a range reduction. So it's kind of the range reduced down. And within its last few thousand years, it was mostly in southern China. So we've done a project the last 3 years looking at sites. We've excavated hundreds of caves, but dated about 22 of them, and looking at what happened to this giant ape. It's the only primate to go extinct in the last 2.6 million years. We survived. So why did we survive? And this massive ape, very robust looking ape, didn't survive, So that's what we've been looking at the last 3 years or so, trying to work out exactly when it went extinct and looking at the causes for its extinction, which is really, a story for all of us about megafauna extinction.
Yeah, an ape that big wouldn't be of a mind to take much back chat, I would have thought.
Not a lot of back chat.
Giganto, I think you're calling him.
We call him Giganto.
Giganto, the giant ape. Yeah. Is it possible that humans hunted this ape to extinction like humans did to so many megafauna?
We definitely know that humans were around at the same time, 300,000. They were definitely humans in Zhoukoudian in northern China, but we don't have any evidence that spatially they were in the same area.
This is completely fascinating. Are you looking for an entire skeleton of this beast, or what do you...
No, so we only know Giganto because of mandibles, so jawbone, and we've found about 1,000 teeth, but nothing else at the moment. So we don't know anything about it apart from a jawbone, which we've made to rescale to work out its size and its height. So at the moment, the big hunt is to try and find something post-cranial, something outside of the head area.
You see, I don't care so much about the Jurassic Park project for dinosaurs. I want the megafauna to come back.
I know.
That would be so much cooler for me,
So
I think, to
good.
see these giant diprotodons, huge wombats, gigantic lizards. Anyway, that's just my thing. I don't expect to get much purchase with that. Kira, it's been amazing speaking with you. What a fantastic story. Thank you so much.
Thank you.
For more episodes, hit subscribe or grab the ABC Listen app and listen to this show and many others all ad-free.